Hi everyone, Assalamualaikum. In this video, we are going to discuss example 2 under non-homogeneous equation for second order ODE. Solve the second order equation y double prime minus 4y prime plus 4y equals to cos 2x. Okay, this is non-homogeneous equation because right hand side not equals to 0. And this is second order ODE because we have derivative with second derivative. Okay. Alright. We record back the procedure to solve non-homogeneous equation. First step, okay, we find the general solution YG. We solve homogeneous equation. Homogeneous equation means we write y double prime minus 4y prime plus 4y equals to 0. Alright. From the original question, right hand side not equals to 0. So this is non-homogeneous equation. But under step 1, to solve non-homogeneous equation, we need to solve homogeneous equation. Means we write right hand side equals to 0. Okay. Then under homogeneous equation, after we write right hand side equals to 0, we need to replace y double prime equals to m2. We replace y single prime equals to m, which is m to the power of 1. And we replace y by 1, which is m to the power of 0. Okay? So we replace y double prime by m to the power of 2, replace y single prime by m to the power of 1, and replace y by m to the power of 0. But we just write 1 for m to the power of 0, and we just write m for m to the power of 1. Okay? Then we get this. Okay? Y double prime equals to m squared. Y single prime equals to m. Y equals to 1. So 4 times 1 equals to 4. This is called quadratic equation. Okay? Because we have degree 2 here. And in homogeneous equation, this is also characteristic equation. Okay? And because this is quadratic equation, so to solve quadratic equation, we can use either factorization method or we can use quadratic formula. Okay. Alright. Since this quadratic equation can factorize, so we factorize it. Okay. So when we factorize, we get m minus 2 times m minus 2 equals to 0. So m1 equals to 2 and m2 also equals to 2. So m1 equals to m2. Okay, this is called repeated real roots. Okay, so we can write m only. Okay, m equals to 2. Right? Alright, after that, we write the general solution YG based on the types of root here. Okay. Okay, so the general solution YG, alright, we can refer from this formula. Now we have repeated real roots. Okay, m1 equals to m2. Okay, so the solution is given by this. Okay, alright. So in this case, we write y equals to yg here. Okay, so yg equals to c1e to the power of mx plus c2x e to the power of mx. Okay, this is general solution for repeated real roots. Okay, or to identify whether this is repeated roots, okay, we also can find the value of b squared minus 4ac. Okay, then we will get equals to 0. Okay, or we can straightforward factorize here, and from the answer, we get m1 equals to m2. So from here, we also can identify the roots is repeated. Okay. Alright, so after that, we replace the value of m here. So we get yg equals to c1e, m equals to 2. So e to the power of 2x plus c2x e to the power of 2x. Alright. Alright, from the previous slide, we done step 1. Okay, we find general solution YG. Now we continue with step 2. Okay, find the trial solution YP. Okay, we solve non-homogeneous equation. Okay, So from the given question, okay, we have right hand side equals to cos 2x, which is cosine. Okay, so we can refer from this table. Okay, if we have Rx equals to cosine or trigo here, okay, then the trial solution Yp, okay, equals to A cos 2x plus B sin 2x if the angle is 2x. Okay, alright, if right hand side in terms of sine only, we also use Yp equals to A cos and B sin. Okay, the angle we refer from the original angle, okay, or the given angle. Okay, and if Rx is given in terms of cos and sine, we also use cos and sine. Okay, means for cos only, we use cos and sine. For sine only, we use cos and sine. And for cos and sine, we also use cos and sine. Okay, alright, so we use this formula for Yp or trial solution. Okay, so we can write the trial solution Yp equals to A cos 2x plus B sin 2x. Okay, we write angle 2x here because the given angle equals to 2x. Alright. Okay, after that, we recall back the procedure to solve non-homogeneous equation. After we write the trial solution Yp here based on Rx, okay, then we need to find Yp prime, means we differentiate from Yp. Okay. Alright, so when we differentiate, so we still have constant A here, and then we differentiate cos 2x, we get negative sin 2x, and then we differentiate 2x here, so we get 2 here, we put in front. Okay, so we get negative 2A sin 2x. And then when we differentiate B sin 2x, we still have constant B here, and then we differentiate sin 2x, we get positive cos 2x. Then we differentiate angle 2x here, so we get 2 here. Okay. Alright, and after that, after we find Yp prime, we need to find Yp double prime. Okay. So when we differentiate Yp single prime, so we get Yp double prime. So we still have negative 2a constant in front. Okay. And then we differentiate sin 2x, we get cos 2x. And then remember to differentiate 2x here, angle, so we get 2. So 2 times negative 2, we get negative 4 here. Okay, and then when we differentiate 2b cos 2x, we still have constant 2b. Then we differentiate cos 2x, we get negative 2 sin 2x. So negative 2, we multiply by 2b here. So that's why we get negative 4b here. Right? Alright, after we find Yp prime, and Yp double prime here, then we substitute, okay, into the given question here to find the values of A and B. And before that, the reason why we choose A cos 2x plus B sin 2x for right hand side equals to cos only, because when we differentiate cos, we will get sine. Okay. So that's why if the function on the right hand side is given in terms of cos only, we need to write cos and sine also. Right? Okay. So after that, okay, from here, we substitute Yp prime and Yp double prime here into the given question. This is the given question. Okay. So from the given question, y double prime minus 4y prime plus 4y equals to cos 2x. Okay. So we replace y double prime by yp double prime. And then minus 4. We replace y prime by yp prime. And then plus 4. We replace y by yp. And then equals to cos 2x. Alright. Alright. And then we replace yp double prime here. Okay. Equals to here, okay, negative 4a cos 2x minus 4b sin 2x, okay, and then minus 4, and then we replace yp prime equals to negative 2a sine 2x plus 2b cos 2x. Okay, and then plus 4 yp. Yp we replace by a cos 2x plus b sine 2x. And then right hand side still equals to cos 2x. Alright? Okay, and then we simplify, we expand first. Okay, we have negative 4a cos 2x minus 4b sine 2x. Then we expand negative 4 in bracket here. So we get positive 8a sine 2x. And then negative 4 times 2b, we get negative 8b cos 2x. But we arrange based on the same coefficient. Okay, so it's easy to simplify. Okay, and then plus 4a cos 2x here. And then plus b, 4 times b sine 2x. So we get positive 4b sine 2x here. Okay, we arrange based on the same coefficient. Okay, from here when we expand, actually we get sine first, but we put sine at the back because we want to arrange based on the same coefficient. Okay, so all of this equals to cos 2x. Okay, and then we can simplify. So we have negative 4a and positive 4a here. Okay, so we can simplify it. Okay, and then we have negative 4b sine 2x and positive 4b sine 2x here. Okay, so now we only have negative b cos 2x plus 8a sine 2x equals to, alright, for cos 2x, we can write constant 1 in front here. Okay, so we have 1 cos 2x. Okay, and from left hand side, we also have sine. Okay, so we need to write term containing sine. But in original question, we don't have sine. Okay, so we can put 0 here. Okay, because 0 times sine x equals to 0. Okay, means nothing here. Right? Alright, from the previous slide, we stop until step 2. Okay, we get negative 8b cos 2x plus 8a sine 2x equals to 1 cos 2x plus 0 sine 2x. Okay. Alright, we recall back under step 2. Okay. In the previous slide, we done write the solution, the trial solution yp based on Rx. And then we done find yp prime. We done find yp double prime. We now under step substitute yg, yp prime and yp double prime into the given question to find the values of a, b, and if we have c. Okay, but now we only have a and b. So now we in the step of to find the values of a and b. Okay, so to find the value of a and b, okay, by comparing the coefficient of cos 2x. Okay, from left hand side we have term containing cos 2x, and from right hand side we have term containing cos 2x. So we compare negative 8b, okay, equals to 1 because both of these are coefficient of cos 2x. So we compare. Okay, so we can write negative 8b equals to 1. Okay, and we have b equals to negative 1 over 8. Okay, after that we compare the coefficient of sine 2x. Okay, we have coefficient of sine 2x here. Okay, so we can write 8a equals to 0. Okay, that's why we put 0 sine 2x here. Okay, alright, so after we solve, so we get a equals to 0. Alright, so now we find the values of a and b. Okay, so after that we continue with the next step. Substitute the values of a, b into yp. Okay, so now we substitute the values of A and B into YP. Our YP from the previous slide equals to A cos 2x plus B sin 2x because our right hand side is given in terms of cos 2x here. Okay, so our YP equals to A cos 2x plus B sin 2x. Okay, alright, so from YP here, so we replace A equals to 0. Okay, this is A. So we replace here. So equals to 0 cos 2x. And then plus B. B we replace by negative 1 over 8. So we get negative 1 over 8 sin 2x. Okay, then 0 times any value equals to 0. So our YP equals to negative 1 over 8 sin 2x. Alright? Alright, and then we recall back from the procedure to solve non-homogeneous equation. Okay, after we find YP, okay, we continue with step 3. Find the solution Y. Okay, Y equals to YG plus YP. Okay, alright, so from here, we continue with step 3. Find the solution Y. Okay, Y equals to YG plus YP. Okay, so from Y equals to YG plus YP, okay, we recall back our YG in the previous slide equals to, okay, equals to YG in the previous slide equals to C1e to the power of 2x plus C2x e to the power of 2x. So we write here. Okay, and then plus YP, okay, YP equals to negative 8 sin 2x. Okay, so we put here. Okay, alright, so from here, okay, this is the final answer because the initial condition is not given here. Okay, so this is the final answer. Right? Okay. Is my answer correct or wrong maybe? Okay, we can check the answer. From the final answer, we get y equals to C1e to x plus C2x e to x equals to 1 over 8 sin 2x. So to check whether the answer is correct or wrong, we can differentiate back 2 times. Okay, so when we differentiate y, we get y prime here. So now we have constant multiplied by exponential function. So we still have constant C1 in front. And then we differentiate e to the power of 2x. So we get back e to the power of 2x. But after that, remember to differentiate the exponent. Okay, we differentiate 2x, so we get 2 in front here. Okay. And then plus, now we have multiplication between variable x here and exponential function with variable x here. So in this case, we need to use product rule to differentiate. Then we get this. Okay. We discuss later. Okay. And then when we differentiate 1 over 8 sin 2x, we still have constant negative 1 over 8. Then we differentiate sin 2x, we get cos 2x. Then we differentiate 2x here, so we get 2. So 2 in front, we can simplify with 8 here. So that's why we get negative 1 over 4 here. Alright? So from c to x e to the power of 2x, okay, we differentiate using product rule and we get this. Okay? Okay, this comes from, okay, when we use product rule, we let u equals to c2x. And v equals to e to x. Before that, when we should use product rule? Okay, when we have multiplication between variables. Okay, alright. So when we differentiate c to x e to the power of 2x, we can use product rule here. Okay, vu prime, we cross multiply vu prime plus uv prime. Okay, so v times u prime, so we get c2e to x plus u times v prime, so we get 2c2x e to x. Okay, so that's why we get this. Okay, so from here, when we differentiate, the answer is C2 e to x plus 2C2x to x. Okay, that's why we get this, yeah? Alright, and after that, we differentiate y prime, so we get y double prime, okay? So from 2C1e to x, we don't need to use product rule to differentiate because 2C1 is a constant, okay? So we still put constant 2C1 in front and then we differentiate e to x. So we get e to x and then we get times 2, and times 2 we multiply by 2C1 here, that's why we get 4C1, okay? And for C2 e to the power of 2x, we also no need to use product rule to differentiate because C2 here means constant. So when we differentiate, when we have constant in front here, so we still have constant C2. And then we differentiate e to x, we get 2e to x. Okay. But for 2C2x e to x, okay, this is multiplication between variables. Okay. So we need to use product rule to differentiate. Okay. So to differentiate 2C2x e to x using product rule, okay. Okay, our u equals to 2C2x here, okay. And then our v equals to e to x, okay, from here, okay. Then from u, we differentiate to find u prime. So we differentiate 2C2x, we get 2C2. And then we differentiate v, we get v prime, okay. We differentiate e to the power of 2x, we get 2e to x. Then we cross multiply, so we get derivative of 2C2x e to the power of 2x here equals to product rule formula vu prime plus uv prime. Okay, so we cross multiply here, so we get 2C2 e to x, and then we cross multiply here, so we get 4, 2 times 2 equals to 4, C2x e to x. Okay, we multiply this, right? So that's why we get derivative of 2C2x e to x from here equals to here. Okay, 2C2 e to x plus 4C2x e to x. Okay, and then to differentiate negative 1 over 4 cos to x, we don't need to use product rule. Okay, because this is multiplication between constant and function. Okay, so we still have constant negative 1 over 4 in front, and then we differentiate cos to x, we get negative 2 sine to x, and negative 2 we multiply by negative 1 over 4, that's why we get positive 1 over 2 after we simplify. Alright, then after we find y, y prime and y double prime, okay, we substitute into the left hand side question. Okay, and we show that the left hand side equals to right hand side. Okay, if the left hand side equals to right hand side after we substitute, means the final answer here, y here, is correct. Okay, so now we substitute y, y prime and y double prime into left hand side question. Okay, so from left hand side, we have y double prime minus 4y prime plus 4y equals to, alright, y double prime equals to this, okay, the purple color here, okay, and then minus 4y prime. Y prime is the green color here, okay, but now we must multiply by negative 4. So negative 4 times 2, we get negative 8. Negative 4 times C1 here, we get negative 4 times C2 here, we get negative 4C2. Negative 4 times 2C2, we get negative 8C2. Negative 4 times negative 1 over 4, we get positive 1. Okay, cos to x. Okay, okay, from here we arrange, okay, based on the same coefficient. Okay. Okay, so it's easy to simplify. And then plus 4y. This is y, the orange color. Okay, so we multiply by 4. Okay, so we have 4c1 e to x. And then c2x e to x, we multiply by 4. So we get 4c2x e to x. And then 4 times negative 1 over 8, we get negative 1 over 2 sine 2x. Okay? We arrange based on the same coefficient. The first term containing C1 and e2x. The second term is the term containing C2 e2x. And then term containing C2x e2x. And then term containing cos. And then term containing sine. Alright. Okay, from here, we have 4C1 and then plus 4C1, 8C1, and then minus 8C1. So we get 0. Okay. And then from here, 2C2 plus 2C2 equals to 4C2, and then minus 4C2. Then we get 0. Okay. And then from here, 4C2 plus 4C2, 8C2, and then minus C2. So we also get 0. And then from here, plus half minus half. Okay, same coefficient, sine 2x and sine 2x. So we also get 0. So after we simplify, we get left hand side y double prime minus 4y prime plus 4y equals to, this one is 0, 0, 0, and we only have cos 2x. Okay, and then from here, okay, when we compare from the original question, it is exactly the same. Okay, means that now we show that left hand side equals to right hand side. Okay, we only substitute into right hand side only, but after that we get right hand side equals to the given question. Okay, means that our y, okay, is correct. Right? Coming up next, more examples for non-homogeneous equation. If you like this video, you can subscribe. Okay? Thank you for watching. Stay tuned. Bye. Assalamualaikum.